Hi, everyone. Welcome to the course. We are going to talk about achieving transformative business outcome with AI. My name is Ranjita Singh. I'm the VP of Data Science and Artificial Intelligence at Teradata. My team is responsible for incubating AI capabilities all the way from its inception, building a business case around it, building a prototype, piloting it with lighthouse customers, and then figuring out whether it makes sense to integrate with the product. And joined with me is Nick, who is my partner in crime. He's the marketing director for artificial intelligence. Nick, would you like to introduce yourself?
Yeah, I'm happy to do so. Thank you, Ranjita. So my name is Nick Swatonik. I am a marketing director for artificial intelligence, and I'm involved in a lot of our efforts around advanced analytics, product marketing, and services marketing. So I'm delighted to be here with Ranjita. And we're excited to share with you some learnings that we've had from many engagements with customers across a variety of industries.
Thank you, Nick. How many of you recognize the picture of this girl? Anyone? Okay, she is a 16-year-old teenager, Kavya Koparapu, who presented her deep learning-based eye disease diagnosis tool at the AI conference, O'Reilly AI conference in New York. Now, her tool can detect the retina and figure out whether it's diseased or normal. Here is another teenager. His name is Abu. Now, he's a very interesting case because he taught himself machine learning and deep learning using online videos and tutorials, and developed an application that can detect breast cancer from mammograms. He was here at the O'Reilly conference in San Francisco last year, and also was at the keynote at Google I/O Developer Conference. What do these two examples tell us? Well, for sure, we are not in the AI winter anymore. Not only are the well-funded research labs at companies like Google and Facebook innovating to really address long-pending AI challenges, but look at these self-taught teenagers. They are really leveraging AI to solve societal problems. Now, it makes you wonder if these teenagers can jump in and solve all these AI problems and can develop all these useful tools, where do enterprises go wrong? Where do a team of experts who are really well-funded, where do they run into problems when they implement AI? Let's take the case of one big company whose partnership with MD Anderson, one of the world's top cancer research institutions, fell apart when the company could not deliver on its promise of AI-driven medicine. All the internal documentation of the company shows that a lot of cancer treatments that were recommended by the company's system were deemed unsafe and incorrect, not just by the customers, but also by the company's internal medical specialist. So when enterprises try to implement things or implement AI, where do things go wrong? Let's look at the artificial intelligence or data science life cycle. There are challenges at every step of the artificial intelligence and data science life cycle. And any of these challenges are enough to derail your artificial intelligence project. If you look at the first step of business understanding, it's very important to map your AI models to the business processes that affect the business outcome. You have to really care about the KPIs that the businesses worry about. Then when you move to the next stage of data understanding, you have to understand the various data sources, internal data sources, the external data sources that can help answer the business question. And then when you get to the data preparation stage, which is also called the data cleaning or data wrangling phase. This is perhaps the most tedious, time-consuming, and boring task deemed by data scientists, where they spend a lot of time. Now, at the data preparation stage, they have to they have to worry about all the data quality issues. The data that is collected or acquired from various sources may not be in the format required to really run your AI models. And it may be full of errors, inconsistencies, semantic errors that you have to worry about. Then we move to the modeling stage, which is the core activity of the AI data science lifecycle. There are diverse machine learning techniques that are applied to find the best machine learning model that fits your business needs. This stage is slow, brittle, and requires a lot of expertise. Moving on to the next stage, which is evaluation. Here, the data scientists have to worry about how do you level the playing field across models from many different engines. What kind of data sets, validation or training data, evaluation data sets that you should be using to really evaluate the performance of your machine learning models. And then we get to the deployment stage, where you have to think about really deploying your AI models in the production environment. And you have to map it to the existing business processes. Remember that prior to this stage, you were working in a pre-production environment, and now your deployment environment may be very different from the pre-production environment, and you have to take that into consideration. Now, rather than dwelling into challenges for implementing the AI project, let's look at some of the, how the enterprise AI should really be done. We are going to walk you through some of the war stories and the lessons learned as we dealt with several customers across different segments to implement enterprise AI projects. Now, as we worked with the customers, 3 key themes emerged. First, it's so important to set the problem right. Second, you have to manage the risk. You have to manage the risk that could derail your enterprise AI project. Thirdly, you have to prepare and plan for all the stages of the AI software development lifecycle. So what does this really mean? What does setting up the problem right mean? Albert Einstein once said that if he was given 60 minutes or 1 hour to save the planet, he would spend 59 minutes in framing the problem and just 1 minute in the actual resolution. While this may sound really extreme, it does emphasize the importance of framing the problem. Now, there are 3 things you have to keep in mind as you are you're setting up your problem correctly. First, you have to design for the business context. Enterprise AI has to serve the business. You need to understand what are the key performance indicators that affect the business outcomes. And you have to tune your models to optimize those business outcomes. You have to understand the data context. You have to understand the various data sources. You have to understand how to do a solid data integration. And that's what makes a difference between a transformative AI and a useless AI. And then you have to build for the deployment context. You have to really understand what is the environment in which you are deploying your models. Now, it will all make sense as we walk you through some of the customer stories, and it will drive the point across. So if you look at the picture on the left-hand side, that's the picture of a retail store. One of our customers is a telecommunications service provider that has many retail stores. Now, they have various KPIs that they use to measure the store revenue. One of them is called accessory attach rate. That is a complex function of price, brand, store layout, characteristics and behaviors of the customers, characteristics of the sales associates, and time of the day. Now, they wanted to use artificial intelligence-enabled computer vision to look at the video footage and figure out which of these factors really have a strong bearing on the accessory attach rate. And artificial intelligence really makes it possible to analyze all these additional data and drive valuable insights out of that. Now, if you look at the example on the right-hand side, it's a totally different sector. It's an industrial environment where you're looking at a manufacturing line. And there are totally different KPIs that come into effect. First is the yield loss. The second is the unplanned downtime. That's what you're optimizing for when you're doing the industrial inspection on a manufacturing line. Now, you have a lot of machine data. You are collecting all the sensor data, whether it's temperature, whether it's humidity, whether it's pressure. You can marry it with high-resolution images taken on the manufacturing line and run deep learning on it to really give you better insights and help you really figure out when the fault is going to occur and do preventive maintenance. Now, you can see that the data that you are collecting in both these examples are very similar, but you are actually optimizing for very different business outcomes or very different KPIs. Understanding the data context. Now, it's, while you have to worry about the business context, you also have to think about all the different data streams that are out there. If you take the case of, again, industrial manufacturing example, you have the line scan cameras that are taking images once every second. Now, that's a lot of data to pipe through your machine learning, deep learning model, or your defect detection algorithm. But as you are looking through this, you also have to look at additional concerns. Obviously, when you are collecting data once every second, this data has timestamp associated with it. But you have to look at all the other data streams and figure out, are the timestamps synchronized? And to what extent? What is the precision? You have to also look at track and trace. So when your images that are going through your defect detection algorithm, it comes up with a defect. Can you locate that defect on the product in the manufacturing line? So these are some of the important considerations to take into mind, because if you don't really have a solid data integration, your AI project is not going to be really serving its value. Building for the deployment context. This is very, very important. And if you look at the example on the left-hand side, it is from a banking company. Now, in the financial segment, you want to control the frauds. You have to detect the credit card fraud in the transactions. And when this customer came to us, we looked at how we could apply machine learning and deep learning to really improve the fraud detection rate and also reduce the number of false positives. Because false positives are more about legitimate transactions that you have to really manually intervene and figure out if it's really okay to go through. And that delays the transaction processing time. It provides poor customer experience. So while we were working on this, we had to think about what are the operational technology currently in play. So if there are rules engine that are already in play, we had to take that into effect. And Nick is going to walk us through some of the consideration that we take into mind as you look at the existing operational technology. And he's going to talk about reuse and so on. Now, the other consideration that we had to keep in mind was all your deep learning processing has to occur within the latency constraints of the transaction monitoring SLAs, right? So if the transaction monitoring system SLA is a certain number of milliseconds, you have to complete all your processing within that time limit. The example on the right-hand side is from a car company. Now, this car company wanted to provide a service to its customers to detect an iconic model across all its derivatives, all its variants, whether it's running in the wild, whether on the road. And obviously, artificial intelligence-enabled computer vision could help there. But as we were thinking about the computer vision, there were a lot of technology and design considerations that surfaced, right? Are you taking the picture of a fast-moving car, or are you taking a picture of a standstill car? is, what is the resolution of the image that you are thinking about? Where should your deep learning model reside? Is it at the edge? What kind of compute and I/O requirements you have to worry about? So these are very important considerations to keep in mind as you are thinking about deploying your enterprise AI project. And with that, I turn it over to my partner in crime, Nick, to walk us through managing risk and the life cycle of the projects.
Thank you, Ranjita. Great. So if you've set the problem up right, then you've already set yourself up for a better chance of success with your enterprise AI project than if you've kind of plowed ahead without considering the business data and deployment context. Now you've got something that you're trying to deploy. You still have a lot of sources of risk that you do have to manage. Let me see if I'm going the wrong way. And there's three types of risk that I want to call your attention to. One is a risk surrounding systems, where our upshot advice is basically we want you to complement existing systems. Don't try to replace them with an AI-based system. There are social risk. We think you can head off if you foster shared goals. And there's also legal and compliance risks. And we think there simply we want to embrace compliance proactively as opposed to trying to beg for forgiveness afterwards, after you've tried to deploy something and it's caused some legal trouble. So complement, don't replace. So there's often, and especially this has been fed by a lot of hype around AI, that you will have this kind of transformation and that the AI is going to be better than existing systems and that AI ought to simply replace those. You should rip out the existing systems and replace them with AI systems. That is, and I think here, I don't know how many of you are local to the Bay Area? Okay, how many of you are visitors? Okay, so I mean, for here, so the verb disrupt is especially prevalent in this area, and I don't know, maybe I'll be disruptive to say that like disruption is for teenagers, so like in the enterprise, like disruption is not what you want, especially with your existing high value business processes. You want those to be, you want to be relatively conservative there. You can be a hipster on your free time. You need to make sure that your business processes are really rock solid, and that when you're trying to bring in the new, that it actually is incorporated and provides an incremental and marginal improvement rather than something that's entirely disruptive. So we want you to complement the existing systems rather than ripping them out and replacing them. So, for example, in a fraud detection use case, a lot of banks will have these legacy systems that they've used for decades that are entirely rules based. Right? So they'll have a rules engine. If there is if a transaction takes place within this time window, and then there's a distance between where that transaction took place and the other transaction takes place, then you raise a red flag, and that's a potential fraud instance. So that's purely logic driven. There's a rules engine, a long list of hand-coded rules, and they meet really tight SLAs, and they're battle-hardened systems. They throw off a lot of false positives, so that's something that we could try to improve on, and we have for clients used AI systems to really dramatically improve on reductions in false positives, things that should not have been flagged as fraud, but we still incorporate our AI models together with existing systems, the existing rules engines, rather than trying to replace them entirely, because there's so much of value there. It is battle hardened. We want to incorporate and integrate the new rather than replace the old. Likewise, on the factory floor, for any kind of yield management, where we're using AI for defect detection, there too are lots of rules-based aspects, logic built into the controllers on the factory floor, and we work with those rather than replace those. And we recommend that you do the same. It's a way of building trust and a way of maintaining continuity and really also building traction for your AI projects. I mentioned a social risk. So AI has, of course, a lot of hype. Data scientists and especially AI machine learning engineers are are the rock stars often of these resources. There can be a lot of grumbling. So why is this AI guy getting paid so much to come in here? If I'm a business analyst or maybe I'm an old school statistical modeler, there can be and oftentimes, if you have this AI person, they're bringing in with them not only this hype and elevated expectations, but also expectations of, well, what's the technical debt going to be like when I try to deploy an AI model? I've already got trouble trying to translate that R-based model into something that I can put into production. What's going to be like with TensorFlow? So there can be a lot of kind of social pushback inside of organizations. And we find that just kind of keeping people on the same page about what you're trying to achieve. So let's say in the fraud detection use case, what are our model metrics that we're really looking at, and then also acknowledging some of the limitations of AI. Right. So AI is not going to be an AGI that's going to blow out of the water any existing models. And we want to acknowledge those weaknesses and elevate the strengths of what exists there already. So we see that as a way of kind of building trust in these newfangled technologies that are go under this label of AI. With regard to compliance. There's so many opportunities. So in a retail setting, it's certainly possible to use computer vision to label the behaviors of everyone in that store, right? On an ongoing basis. And that includes not only employees, but also customers. Now, that kind of ongoing continuous surveillance and labeling of your customers may raise red flags with your legal department. And you should say, okay, well, how do we, let's talk through that compliance. It requires some sophistication, but also proactivity on your part of the team, the AI team, to be looking ahead to yes, there's things that we can do. Which of those should we do, and which of those are going to are within scope? So for one retailer, we brokered a conversation about those issues, and we're able to say, well, great, our employees, we can surveil as much as we want. We can label their behaviors, and we care about their interactions with our customers, so that, and we can tie that back to whether those customers are buying something. Are they attaching accessories at the end of their visit to the store, and based on sentiment detection of the faces of the employees. There's a lot of things that can be done, but we need to identify the employees and non-employees, and non-employees need to be given some special consideration and temporary IDs that are then flushed. So there's this embrace of compliance is really essential to making sure that you just don't have a real legal problem and a scandal on your hands that's tied to your AI efforts. Great. So again, you're trying to plan for a lot of different, plan for success, identify some of the downside risks and try to mitigate them to the extent that you can. If those are in place, then you might actually be able to deploy an AI model that gives some ongoing business value. But even there's some other things that you need to think through. In particular, you want to be thinking about the life cycle of a project. And this has a lot of familiar, if you're deploying any other machine learning models, there are some family resemblances here, but there's some distinct qualities to AI that also are worth highlighting. So in particular, this kind of goes back to building trust in the social setting. You want to have a framework for enabling continuous improvement, right? So AI should not be a one and done type thing, that you want to be able to continuously improve on that. That can mean doing more model search. It can mean adding more data, doing some more data pre-processing. And so having a framework that supports that, whether it be a model management or something along the lines of analytic ops, so that you have a hardened way of continuously improving on what you've achieved with AI is a really critical thing, a critical aspect of the life cycle of your AI efforts. And AI, of course, as with other machine learning models, relies on a lot of data pre-processing. So managing the dependencies of your AI model, pushing those into the appropriate places for pre-processing is a really crucial thing for the longevity of AI projects. And likewise, some of the intermediate results that come from the automatic feature generation of AI models are things that could be that can be managed as additional assets that can be reused. So we want to plan on also reuse of AI assets. So among the things that we get with an AI model is we not only get, say, scores or within a classification setting, but we can also get a new representation of input data that might also be available. We want to make it available for reuse in other settings. The AI model itself, if you've customized that to the line scan camera data for a particular manufacturing line within a factory setting, that's a lot of work that you don't want to have to start over from scratch on the next line over. There's some learnings and some IP that you have built that is custom within your firm that you'd like to be able to reuse in another line, either as is or in a kind of transfer learning sense, that you're going to take that and maybe retrain just a few layers instead of starting from scratch with a full search for the architecture or for hyperparameter optimization. So thinking ahead to how having a lot of metadata around the AI models that you've built, and also capturing information about what you've learned about the predictors to those AI models, so that too can be reused. That these are useful inputs for a model of this type, and they require this kind of pre-processing. Are considerations that you'd like to have processes and platforms to support. Great. So, in summary, we think that the success of transformative business outcomes in an enterprise setting really depends on getting straight on three main things. So make sure you're setting up the problem right. Okay, you're thinking about the data context, the business context, and the deployment context. Make sure you manage varieties of risk, including compliance risk and the social risk within the organization across departments, and prepare for the life cycle. Thinking about the models, about the reuse of the components of the models, and of pushing some of the pre-processing into the right places to make sure that those models can be deployed on an ongoing basis. Great. Thank you so much for your attention. We'd like to open the floor for any questions or suggestions.
Hi, I'm Anju Sharma from HP Inc. We make PCs and printers. And we recently deployed a chatbot for customer service that depends on an AI model for NLU, for the intent matching. And the problem is HP, we know our data, we know our business context, but it's all black box, the whole AI model creation, the tuning, and then the training and all that. So what I'm worried about is it's not clear to me if we switch vendors to do a new model, what I should have known about the whole process they went through. Because it's working really well, but it's all just one big black box, your middle layer for us. And I don't really have a question. I think that it just exposes us to maybe doing things a little bit more, not having it so much a black box next time.
So you're using NLU as you're getting from as a service. So there's AI as a service, right? Yeah, so I mean, I think that is definitely I think all of us, as we're thinking with kind of like scarce resources around AI, do we make it? Do we make it, or do we buy it? And if we buy it, then we're going to expose ourselves to that kind of that risk of not understanding how the thing how the sausage is made, and whether we'll be able to maintain it. It could be cheaper in the short run, though, and it might be the right way to kind of get into something. I think that we do see among some of the vendors, maybe some improvements in customization, but not a lot of like lifting of the veil of how that the black box works. So. Certainly, from our perspective, both in our consultative engagements and I mean our approach has been to empower our customers to have a bit more insight, but it does mean a larger upfront investment, either in personnel or in whether it's kind of staff augmentation through our kind of consulting organization. So I think that's a very familiar issue, and some of them have to do with just some of the challenges of these complicated models. There's improvements in kind of shining light into black box models, but having some team that's able to make some improvements, understand what the technology is doing, owning that. Especially, I think the customer care chatbot maybe is not considered quite as strategic, within HP Inc. Maybe if you see yourselves as more as a manufacturing company, I won't speak necessarily for you, right? But you might say, okay, well, I don't see that as necessarily strategic. But on the other hand, maybe customer care is really strategic. We need to own that. And part of that's going to be AI. We need to understand how we can better serve our customers, and it's really essential to understand the insight. So I appreciate your sharing that. I'm sure that's a common concern for a lot of people here.
Yeah, two quick comments. One is I don't think black box is the right way to go. It would be good to set ourselves up to have at least some transparency. Yeah. And second comment is in terms of a strategic nature, we did learn the process of going through this exercise, and so that process we're kind of propagating throughout the company. So we're in a bit of a strategic role there, cool, as well as roles that we need to support it.
Yeah.
Yeah, and I think with any initiative, you have to go through the typical build versus buy, right? And if you think there is a lot of reuse of what you're going to do here, and you have similar use cases that you will be utilizing it or enhancing your current implementation for additional use cases, then I think it makes a lot more sense to really build, because then you can enhance it and you have a lot more transparency into what you have implemented.
Someone back there.
So I'm tempted to continue this discussion because I'm facing the same thing. So I work for FICO from San Diego, and you guys are located there too. So one of the things that whenever AI is applied, some of our customers have come to expect a good reporting and performance monitoring afterwards. So performance monitoring is it doing the right thing, getting better, like you mentioned before, right? Yeah. The other one is reporting. Like, so you might have a chatbot black box running the chat, but you still have the transcripts of the conversation. Now you can apply the same NLP techniques and mine that data to see what are the interactions that are drawing customers in versus pushing them away. And what are the trends? What are they complaining about? So you could add or slap on another layer of reporting and performance monitoring to make sense of that. You might not know exactly why the chatbot said something, but you can always then question it if there is a pattern to it, right? So that's and we face that in fraud too. So we have fraud models that that improve performance, and sometimes you don't want improved performance because you're going to then overload your customer call centers. So you want to optimize it. So reporting, performance reporting, and mining of that performance, I think, is a vital part of deploying any AI.
Yeah, those are really great points. And I mean, I heard you say a number of really interesting things. One is that just like using AI to explain AI, which was a really interesting and novel and kind of turtles all the way down approach. I like that. That's very cool. Any other reactions to the?
I found it very interesting. I think, one of the interesting things that I see happening with the IoT, with artificial intelligence, it is more of a, I would call it more of an ecosystem play versus one player do it all. And I think what you touched upon brings to light how important it is to have this ecosystem of players. You may decide at what point where you add value in the life cycle and where you could actually leverage an ecosystem player, right? So I think that's the key insight.
Thank you for, thank you for sharing.
So I wonder if you could just say a few words about how to set up your QA department to be successful. I mean, do you need them to be data scientists, or do you leave the data scientists outside and have them work with them, or what have you seen that works?
So, we call it Tale of Two Cities. So I think, what artificial intelligence and data science is doing, it's actually, the players who are going to be successful in this space, and that's just my opinion, are the players who are going to systematically bridge the gap between these various functions, right? Today, you see that there's isolation of data scientists from the QA world, and then artificial intelligence folks are sitting there. IT is a totally on its own isolated bank, right? If you can truly marry all these different groups together and get them to work together, that's the ultimate goal of AI, right? I'm a believer that, as time progresses, the QA function is going to be actually absorbed into the whole software lifecycle. Like, you won't have a separate QA function. The same team that is developing the models is also going to be testing it out and validating it. It's not going to be a totally separate, isolated function.
Yeah. And we've had, and I think that mindset of that sort of development mindset and this DevOps approach is something that we are finding a lot of customers are beginning to embrace, and they see that vision. And we've, for a number of our engagements, have helped our customers work with their existing DevOps processes and started to incorporate AI and machine learning models into that process. So we have an analytic ops framework that extends some of those DevOps concepts into the domain of analytics, and as a way of fostering that really tight integration between the somewhat more research-driven, blue sky kind of innovative, and the kind of like hardened business process, tested, deployed models side. So I think it's a very prescient comment, and certainly something that is we see a lot of the industry moving towards, and we're working with customers to make that happen as well.
I can talk. My name is Syed. Work for Wolters Kluwer. So we have actually like extrapolating on this on the past couple of comments. We have also developed chatbots, and I actually lead an AI team, and we work with business in delivering this chatbot. So the black box and then the validation, the QA, that the comment you made, it's very interesting because the whole process is so fluid. It's hard to define QA.
Yeah.
When what happened is when we developed the bot and we gave that bot to test the business, the functional test, and 3 people came with 3 different results. And these are not like few percentages here and there. They were significantly different. One person was testing the product owner scripted questions and answers. Another person who was SME was testing actual questions and then expecting certain answers. So it was a more realistic test. And then another SME. So even there was no convergence between the 3 tests performed, and then we were doing some black box stuff too, because we were using deep learning neural networks work to back and things like that, So, and when you think about causal modeling, understanding why something is happening, that's a different side of AI. That's how I see it. It's like you then go into causal modeling, where you're defining relationships, and these are very like they have a challenge of because we are linear people, right? People can only understand linear relationships. When it gets into abstract or non-linear, it's very hard to follow through.
Yeah.
And then that also becomes a very limited like a lens to look at problem.
Right.
And then you need many models to understand why is what happening. So I mean, there are these challenges that the industry and the business owners, everybody is facing. It's just the nature of the beast.
Yes.
Yeah, and model explainability is a very big research topic right now with a lot of different techniques out there, but you know, everybody cares about, you know, how do you explain the model how do you explain the results that you just got, and what are the vectors that contribute the most to the results?
So with that, I think we're at time. We're certainly happy to take other questions or engage in conversation either here or at the Teradata booth on the exhibit hall. And thank you again for your attendance, and we appreciate having you here.
Thank you so much.